Welcome to Friday and welcome to the solar system. You should have already read the article, What is the Difference Between a Galaxy and a Solar System, and written a paragraph about the said difference. If you needed to use the graphic organizer, you could have. If you didn't need to use it though, you don't need to use it. So if you haven't read that, you should probably stop the video right now and go back and read that and write that paragraph. If you have read it, then we will just follow along with this. I'm going to read the article. If you don't want me to read you the article, you can shut this video off, play the next video, and answer the questions in full sentences. Or if you'd like me to read this little article to you, just go ahead, sit back, relax, and listen. The solar nebula hypothesis, or nebular hypothesis, is the most widely accepted model of how our sun, planets, and other solar system bodies came to be. According to the model, the solar nebula, a region in a giant molecular cloud of gas and dust in the Orion arm of the Milky Way galaxy, began to collapse and contract under its own gravity 4.6 billion years ago. The collapse was likely triggered by a shock wave from a nearby exploding star or supernova. As the radius of the nebula became smaller, its rate of rotation increased due to conservation of angular momentum, analogous to how ice skaters spin faster when they pull their arms in. So if you sort of think about how they spin faster when they pull their arms in, it's kind of the same thing as far as what happened with the nebula. Eventually, on the order of 100,000 years, the cloud flattened into a disk, so it took 100,000 years for this cloud to flatten into a disk, with the gas and dust orbiting a dense central core, a protostar. So the core of this nebula is called a protostar. Within the core, temperature and pressure continued to intensify, and when the temperature eventually became hot enough, approximately 10 to the 7th power Kelvin, so that's really hot, nuclear fusion was ignited and the sun was born. The protoplanetary disk rotating around the young sun gradually cooled as it radiated energy away, and different elements and compounds began to condense into solids. The materials stuck together, colliding and clumping with each other. Depending on the impacts, the colliding bodies may have broken into pieces or merged together. Through the process of accretion is kind of the buildup by adding layers. That's a word that's, I thought maybe I should just point out. It's like you just keep adding layers of something to get bigger. The gravity of the growing clumps pulled in other clumps, right? Tiny particles eventually grew into giant rocks, asteroids, and planetesimals, bodies up to a few kilometers across. The very beginnings of planets, like baby planets. Planetesimals continued to grow by accretion into protoplanets several hundred kilometers across, like toddler planets, right? Through radioactive decay and melting. Materials within the protoplanets differentiated, so they reorganized themselves into the different layers and compositions that define the planets today. Scientists believe that the formation of the sun lasted approximately 1 million years, and the formation of the planets was completed in approximately 100 million years. So just think about the length of time it took for the sun to get there and for our planet to form. Temperature differences within the disks determine the characteristics of the planets. Metals and silicates, which are rocks, which are dense and stable at high temperatures, condensed in the inner solar system, forming the rocky planets Mercury, Venus, Earth, and Mars. So those are the 4 planets that are pretty rocky. Lighter, volatile compounds, like water, which condense at very low temperatures, formed ices farther away from the sun. The ices, including water ice, frozen methane, and frozen ammonia, combined with the rocks and metals, giving rise to the cores of the massive gaseous planets Jupiter, Saturn, Uranus, and Neptune. Between Mars and Jupiter are tens of thousands of small, rocky orbiting bodies, asteroids. It's the asteroid belt. The asteroid belt is a region where the gravitational influence of a newly formed Jupiter would have prevented the small bodies from amassing into a planet. Beyond Neptune, icy objects that were also not able to grow into planets are located in the Kuiper belt, scattered disk, and Oort clouds. We'll learn about what those are. Asteroids and comets retain much of their original composition from the early solar system. They therefore hold rich clues that may help answer many of the open questions that remain about the solar system's formation and evolution. So that is the article. It's pretty small. There's a video that I want you to watch that kind of goes along with it, so please watch the video. And I also threw a graphic in your packet that just kind of shows how the solar system formed. Yeah, so watch the video, check out the graphic, and then answer the questions. And there are only 6 questions to answer, but I do expect them to be answered in full sentences. And if you feel like the answer merits a paragraph, please use a paragraph. If you need a graphic organizer, I had thrown some extra ones in to everybody's folder. You don't have to use them. They're just there if you want the help. Yeah, so that is the solar system. So there you go. That is how the solar system formed. It's Friday. I will talk to you guys on Monday, and we'll talk about different parts of the solar system over the course of the next week.